All right, well, if this works, like I say, you are going to get, this is the beginning of part 2 of the review lesson for the midterm for physics classes. And we're going to start where we left off at part 1. Again, what you're guaranteed to get on the web is a copy of everything that's been on the board in PDF format you can download and look at. If this recording works, you're going to get my voice commentary describing it, and you're going to be able to watch a movie of what we write on the board here together. So on mophysics.com, you're going to download the questions, you're going to watch this, you're going to look at your lesson materials, copies of which are available on the same website, and you're going to come in here and nail the midterm exam. So here we go. Let's continue where we left off. Here's an example of a multiple choice question. What I'm supplying you with in advance is the question minus some of the quantities minus some of the quantities, and you don't get the answers. So what you're going to see is a selection of answers from which to choose. And in all of this, so you need to figure out how to answer this question so that you can evaluate any answers that are provided to you on test day. Don't fail to, so there will be some number in here. Let's call it 4. Don't fail to make a sketch for anything. Ashley and Thad are pulling a wagon. Which accelerates at 4 meters per second. Okay, I guess we'll just assume it's accelerating that way, though it's not clear. Each is pulling with the same force in the same direction. Make a force diagram. Golly. I give you permission to omit the, yes?
How many questions is the midterm?
A whole bunch.
Like
50.
Okay. What? Is it 50, but like there's like 4 of them are open-ended at least?
And they're plus free response.
Oh,
So it's a big test. It's 90 minutes long. It's going to be a lot of work.
Yeah.
But like I said, it's designed to be straightforward if you've been doing the work that we've been doing so far. And you'll see, because we're talking about these questions. Just draw a force diagram. Always. Make a sketch. Always. There's no reason not to. I'll draw the vertical forces here, though we know they're balanced. And here's Ashley. Here's Thad. FA on W, FT on W. Let's see. If Ashley falls into the wagon, effectively doubling its mass, the sum of the force equals whatever here. So what's changed?
Mass.
Okay. When in doubt, draw a picture. While you draw the picture, you can think about the quantities you know. Well, if the mass here is m, the mass of the wagon here must be twice that. But the total force
Is half. Is half.
Okay? So if the total force up here was, I don't know, F, the total force down here then is,
F over 2.
yeah?
Wouldn't it be a fourth?
How do you know that? How do you know that
What would be a
the
fourth?
total force is getting divided by half?
Excellent question.
Like, how do you know that Ashley and Thad are pulling in the same?
Excellent question. Okay. Claudio.
Wouldn't it be a fourth
Oh,
because
yes.
you no longer have the pulling power of Ashley and you have double the mass? So it's half the force and double the mass.
Exactly. The acceleration is 1/4 of whatever it was. Okay. So Pete, did you see what this is?
Yeah, I see
The language is critical in this stuff, and this is deliberately part of our course. You have to read carefully. What Eugenia told me, you read the question 3 times before you pick up your pencil. That advice has stood me in good stead on many occasions. And that's another way that the sketch can help you. So let's see. up here, acceleration equals whatever that force was over whatever that mass was, and it works out to 4 meters per second squared.
Why? Wait, actually, wouldn't it be F over 4? Because then
What's the
wouldn't
force?
bad?
It's just the force.
Oh, okay.
Okay. So if what's the acceleration then of twice the of 1/2 the force divided by twice the mass?
1/4.
Yeah, that would be 4 times the previous acceleration.
4 times or 1/4?
1/4, of course.
Oh. My bad.
Mr. D, I
Yep.
guess.
You may need to choose another seat because I got to stand somewhere. Okay. So that's not the only way to reason it, and lots of people can figure it out just by staring at it. But double check your work, especially on test day. Here's a similar one. Let's make up some numbers. Simone is pulling a 10 kilogram wagon containing, I don't know, 90 kilogram. Jean-Paul, Jean-Paul is dragging his heels on the sidewalk. I'm getting pretty good at that. And the sidewalk is exerting a frictional force of, I don't know, 300. If Jean-Paul suddenly falls off the wagon and Simone continues to pull the same as before, what will be the acceleration of the wagon? Fun one, huh? Oh yeah. For what option? For what object?
Wagon.
Good. Actually,
Wouldn't it be a wagon with Jean-Paul?
Simone and the wagon.
No, Jean-Paul.
That, yeah.
yes.
They're-
I think that's the thing to do. So, wagon plus Jean-Paul. So,
100.
what do we know about forces? Oh, what's up? Yes.
300 force still
Frictional force, 100.
What? No, it's 300.
300. It's tough to do this after lunch. Force, friction on the object. What else we got?
Force of
Balance,
Simone.
Ah.
Force of Simone pulling the other way at 10. No. Never mind.
Simon.
Yeah, oh golly, that's the trick. How hard is Simone pulling?
We don't know.
If there's
It's unknown.
30 newtons that way,
30.
Simone is pulling, or
Can't you
300 that way.
Can't you just do a
Simone
total
is
of
pulling
force
enough
not?
to move it.
So it's greater
So-
than 300.
Yeah.
So
it
it's
is.
total
variables.
No?
It is 300 because if it's at a constant speed, then
Yeah,
the forces
that's-
are balanced.
Wait, did it say constant?
There you go.
Oh, okay, there you
Thank you, Chayton. Okay.
Constant speed.
Look, if I say
Good job.
tomato, if I say failure, does that get your attention?
Yes.
Yeah.
Okay. If you see constant speed or constant velocity, I want that to get your attention.
So,
I want you to see that in red letters of fire whenever you come across it. And when you come across that, you will think what?
Important.
Balances are balanced.
Yes, whatever the forces are, they add up to 0. Yup. So this has got to be the force of Simone on the wagon, and it's got to equal 300 in the other direction.
yes.
Okay? So, what next?
Oh,
That's how.
oh wait,
Threw it on the
Jean-Paul.
ground.
Yeah, no, Jean-Paul can fall off the wagon.
Threw it out.
Shut up, you guys shut up.
Okay, the rest is left as an exercise to the reader.
What was it? So you would do force over.
Okay, remember your old pal.
So the force would be, so Simone is still pulling at 300.
because it says she's still, or he or she, I don't know.
She?
She's still pulling at the same force, so that would be 300. And then the wagon would be the same. Would be the
Oh
same
yeah,
weight.
that one
minus
is
the weight.
that one's 3.
No, the math.
This one's 30.
Wait, what?
This
What
is
are the
30.
maths?
This is 30.
So
Oh,
now
the
now
mass
it'd be
equals
10.
10.
Yeah, the
Now
mass
it'd
would just be
10
10.
over.
The mass is 10.
So that means the 300 divided by 30 is 10.
Is whatever, yep.
Equals
I
30.
mean 300 divided
Wait,
by 30
but why don't you have to
is
factor
30.
The acceleration equals 30 meters per second, right?
Oh,
Because
you
the friction
friction.
is
It
30.
says sum of all
10 is 30,
forces,
yeah.
so wouldn't it be 300 minus 300 and you get 0 over 10?
No, because the friction was on John Paul, and now John Paul's not in the wagon anymore.
Wait, would it be
Oh, it's
300
just on
meters per
John.
second
Oh,
squared?
because John Paul's
The
going
acceleration
like
is
that to
30
the ground.
meters per second.
So what about the wagon? There's no frictional force on the wagon?
Yeah, but they don't say.
Since it doesn't say so, we'll assume it's got
Yeah.
wheels, we'll assume that friction on the wagon is
So
small enough to
there's
ignore.
no force on the wagon
Except for
going, like,
sludge.
that's making it go the other way.
Oh, is it, wait a minute, is a force required to make the wagon go?
Yeah.
No.
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 Yeah,
But initially, after Jean-Paul falls off, don't remember, continue, read careful.
Yeah.
So it's a constant.
Yes, it is.
So because it's a constant force, it accelerates, right? Because
At least initially,
So the
yes.
acceleration would
If
be
she's-
30?
Yeah, whatever that
30
works out to
meters per
be.
second squared?
kilograms.
Okay.
Kilograms.
So there's no other force on the other direction.
No information about it.
Yeah, it doesn't say anything, so you just assume that it's not.
Cool, nice problem. And excellent stick figures, I must say.
Yeah, your drawing's gonna
Very
be.
accurate.
Getting better. Oh, we have our pretend numbers in there already.
Oh, a curling stone.
Now, who knows what a curling stone is?
Yeah,
Okay, well, then you're all much more culturally informed than me.
The worst sport ever.
Curling for life.
It's a stone that slides on the ice. It's one of the things that they invented in
It's
Canada.
used for
I
student
have no
sports.
idea
It's
what you
really
guys thought.
Canadian.
Yeah. Before we had cable TV, it was long winters in Canada, and nobody really, people really had a lot of things to
We
do.
lived in Canada.
No.
It's all rocks on
We'll
the
call it
targets.
we'll call it ice bocce.
Did you always live in New Jersey?
No, I lived most of the 90s in England.
Are you serious?
I'm absolutely serious.
Are you like English or?
No, I'm a Jersey boy. But I'm kind of surprised to find myself here. But I like it. I'm glad I ended up here after all. Almost didn't.
You guys are fun.
And it's kind of hard to do since you don't have any answers.
Oh.
Okay, yeah.
Okay, momentum is mass times velocity.
Okay, go to what we know. Yes, momentum is mass times velocity.
So they're proportional.
So you can tell that the stone moves faster than the sled?
No.
Yeah, you can.
It has to.
Oh yeah, what am I talking? So it's moving at 14 meters per second, right?
14
Yeah.
times.
Proportional.
Yeah.
Yeah, true. It could be.
So,
Oh, which of the statements are true? Okay. That means the velocity, yeah.
So can you do like less than and equal to, or can you do less than signs here? Or?
what a great idea. So the mass of the stone times the velocity of the stone is going to be equal to the mass of the sled times the velocity of the sled.
That is so true.
Alright. So that means, yeah. Alright.
That's it. Right
So
there.
what if it asks you to, yeah?
That's the answer. Well, we don't have any.
Well, we don't,
answers.
what kind of questions might they ask? It says, what statements are true?
Well, they
The
could
stone's
ask,
velocity is greater than the
yeah, they
sled's.
could ask something like that, like Chase.
Could be.
The sled is moving in the opposite direction.
Ooh, good one. Could they, the
I don't
sled,
know why I would say
Well,
that.
just a trick.
well,
It would.
you've been reading a bunch of my tests.
Tomatoes are red.
Wait, is that even possible if the sled's moving in the opposite direction? No, it's not, right?
Oh, because
So
that's
one would be negative, so they would never be equal.
Yeah.
So I suppose strictly speaking, that is not the same momentum. Though if it said, you never know, if it has the same magnitude of momentum,
Alright, yeah.
then it could be equal and opposite.
The stone could have like a larger external force, like applied to it, than like the most moving that they're like
I think bringing forces into it might be making it more complicated.
Yeah.
But hey, stop. but you're so.
Riding a leopard.
Yeah, I know, because he uses
Oh, that's why it's Christian.
Wait, what else could there be on this like statement thing? I don't know what else.
Velocity of the light is greater than velocity of the
The sled
Okay.
is Peter.
Yeah, you can just do the opposite as the first one.
So, if you know this, you should be able to work out whether any statement is true or not.
Yeah.
Fair enough? And when it's a question like this, and there's a bunch of them, which statements are true, you're going to see choice, 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 and then more than one.
Or none of these.
Yeah, okay. You know how I love those. Yes, those are terrible.
I hate those.
Yep. Well, that's the only reason. That's the only way I can justify to myself giving you multiple choice questions, which are usually a waste of time for people who are doing real learning.
If there's like a question that says that you can choose, but like it says like what you say.
Here's what you do. You go through each opportunity and you mark them up. And you say, let's see, I know this cannot be true. I know this cannot be true. I know that's definitely true.
So was the first one.
And if you know, but mark it up, don't mess up.
So what if you're like, this can't be true, so I'm not certain.
Okay, well if you're pretty sure that that's true, then you're down to judgment call on this. And at this point, be careful with your brain, because your new brain is very capable and you're quite comfortable with the idea that an object can move at a constant velocity with nothing at all exerting an unbalanced force on it. But because that idea is comfortable now, your old brain will jump up and ambush you, and it'll feel just as comfortable. Okay, which object has the greatest amount of momentum? So let's see.
Yeah, I know. Now I know the answer.
What kinds of questions might they give us?
That's answer.
Yeah. How are you going to answer this question?
A ball traveling at 10.
Just like
You can
the
just
choices in
figure
there.
out the momentum of each choice and whichever one's the largest.
Yeah. Yup.
Oh, they were asking for examples.
Okay. What things might be there to fake you out?
Magnitude.
Different directions.
Oh, different directions?
Direction.
Wait, how would you know which way they're talking about? If they're saying like the right is negative, the left is positive.
Oh, what a good idea. How can you tell? Let's see, what if one of the questions is a tank
It doesn't say it's negative.
going in the negative direction at 1, mass equals, enormous. Or a matchbox car going this way at 1.
Will that have the same momentum?
Which is the greater momentum?
Obviously the matchbox.
Sorry, hang on a minute. The greatest amount.
The car. The little car.
But the tank does, because
The tank.
even though they're moving the opposite
Yeah,
direction.
okay.
Wait, so is it?
So what? That would mean. Does that mean magnitude?
Yeah, but can you say
Yeah,
that? Because
amount is the same as, yep.
What? That's
Yeah.
not fun. That's
That
not
makes
cool.
sense.
That's
Wait,
not
of course it's cool. What has the greater amount of velocity? 1,000 meters per second that way or 10 meters per second that way?
1,000 meters per second that way.
No,
Yeah. Negative positive is just a way of saying this way, that way. You're down with that now. Amount equals magnitude equals, kinda absolute value.
Are you recording all of this still?
Yep.
Wow.
Yeah, so you sounding stupid.
It may or may not be able to pick up how stupid he sounds. Which he doesn't, of course. Any thoughtful question is a great thing. So this is a greater amount of momentum. Don't be faked out by the negative sign. Be a thinker. All of these have things for you to think about.
So what if a question says a ball is going to the right and another ball is going to the left?
You know how to treat that.
But how would you know which one's negative or positive?
Who cares?
it
That's irrelevant to the
Absolute
problem.
value.
It's different. Fine, whatever.
Okay. Amount equals the magnitude is the absolute value of the momentum. And think about what it means. With all the questions, everything should have a physical meaning. You know, more momentum, tank that way or toy that way? Okay, this is easy. Let's see.
Do you like cars? Because you involve cars in a lot of problems.
All physics teachers do. But yes, I do. Oh, I mean, not like crazy
Specific
person.
types of cars. You like.
Well, these are my cars.
What was that
So
car?
I don't have much imagination, so everything in the problems comes out of my
What was that
world.
car that you saw, that we saw, the electric one?
That was a mini E. Yes. Yeah. And I'm really bad at drawing them. But if you draw things, you can't go wrong.
What question? Oh, just,
Okay? You draw, you label.
yes,
Let's say it's, I don't know,
what's that?
2,000, 1,000, 9.
2,000. Oh, wait, never mind.
Okay.
I thought it said 2,000 meters per second.
So here you know the mass, you know the velocity, so you're going to get some known amount of momentum. That means for the mini, you're going to know the momentum, you know the mass, so express it in terms of the velocity. So you take that known amount of momentum divided by the known mass of the car, and bingo. And then just look it up in the answers.
It's so much easier to break things down. But like on the test, like,
Yeah.
I can stop.
What?
Like on the test, I don't know, like I feel like I can stop.
I know.
It's obvious doesn't.
The velocity of the bean car, that one, the 1,000 one.
Oh, you know, it's a bean car. Good job. Uh-huh.
18.
Oh, okay.
It's 18 meters per
Yeah,
second.
yeah, this is easy. Yep, absolutely.
What?
Mr. Bean. In the TV show, Mr. Bean drives an Austin Minute. Yeah.
I thought you, okay.
It looks like
Mr. Bean.
Okay. There is a friction force of blah between a box and a tabletop. In order to keep the box moving at a, let's see, which words are written in giant letters of flaming fireness? Yes, yes. Okay. You see this? So you think what?
That forces are equal to 0. Is that
Oh my god, is that a
Is that a
cat?
dog?
Is that a devil?
I was trying to make a satanic
Yeah, a satanic
face,
cat.
but
Satanic cat. Give it some whiskers.
dude? Yes, please.
No one likes cats. Alright.
so as soon as you know that it's moving at constant velocity, you know that the forces have to work out to be balanced. So you know what to look for.
What's the friction force?
Okay.
Can we make a negative 4?
If it were, what would the how fast would you have to push it? Or I beg your pardon. How hard? What force would you have to exert to keep it moving at
4.
constant velocity?
-1.
Okay.
Wait, did you say negative?
I said
Because the total force equals the acceleration over the mass.
you have to do 4.
Boop, boop.
That's the answer? If it was negative 4, the friction force?
Yes. So when acceleration equals 0, the total force equals 0. Good. Couple more forces. Training car A. Moving this way. Being pushed
By a train?
by Thomas the Tank Engine, actually. Because I've drawn a lot of Thomases.
Isn't your son like Thomas the Tank?
Oh, yes. Oh, that's not Tom. That looks more like that looks more like Stepney, one of the narrow gauge engines. Sorry. Anyway, there's his buffers. This should be easy. Just draw a force diagram for car A, and don't mess anything up. The proportions of this exam should be about the proportions of most of my exams. Out of all the questions, they pretty much come in 3 categories. Very easy, moderate,
Somewhat moderate.
difficult. So expect some questions to be very easy. What statement is true of every object that has mass? And yes, I think that's a bit redundant because if it doesn't have mass, it's not an object.
Where's the object?
Oh wait, would there be like selections for this, or would we just be like,
Oh, yeah.
well.
Yes.
So A, it exists. B, it doesn't exist.
Good one. Oh, and you know what else I've reformed a little bit.
C, yes.
Each question only has 5 choices now, and so it's whittled down to 5 on this test. So let's see. What's something that could be? What's something that's going to be true?
It is affected by gravity.
No,
A force can be exerted on it.
I'll say this: participates in gravitational interactions. That is true.
it takes up space.
Who cares about that? When I look
It's true.
I care about that.
doesn't have to do with physics.
Awesome.
Now, what does that mean? Participates in gravitational interactions?
You can see
That gravity.
Gravity pulls down on it.
No, gravity doesn't pull on it.
not
The Earth pulls on
The
it.
Earth pulls on it.
Okay.
Yes. And of course, if Earth is pulling on object,
The
yes.
pulls onto the Earth.
So, in real life, every bit of mass pulls on every other mass.
And if it was the Earth goes to it, or the asteroid goes to the Earth? Wait,
What?
I have a question.
Yep.
So, you're saying that anything that has a mass pulls on the Earth, right? So, what if there was like a gigantic asteroid that would have the same mass as the Earth?
Well, that would be called a planet.
So which one would fly?
And it would not.
Yep.
Okay. All right. Which? Okay. All right. So if Venus, all right, was moving toward the Earth, which one would pull on which? Like which way would?
Wouldn't Earth pull on Venus?
Wait, Earth is bigger.
They have the same mass.
Yeah. No, but I'm saying they have the same mass.
Okay.
I have a comment.
Because if Venus was moving first towards the Earth,
They have the same mass. They're going at the same speed, not like one's
If
faster.
me and Nina are on skateboards holding onto either end of a rope and tug,
you're gonna
who's
win.
pulling harder on who?
You're gonna pull hard.
No,
Uh,
you're pulling, they're both pulling at the same
uh.
I'm gonna cut the rope.
No,
What? First of all, what would you see,
You'd see two
Nina
people pulling in
coming
opposite
towards
directions.
you.
and how would they move?
forward.
Towards you.
Who would accelerate more?
Nina.
Nina, yeah, Nina would accelerate more.
Who's that?
Are you guys pulling at the same
That's Mr. Devano.
That's me.
The small one's Nina.
What would you see? You'd see an enormous delta V from Nina.
Nina might be eaten.
Yes, that's right. It's clearly, and perhaps a barely detectable delta V for me. Why?
Because
Because
has more
Venus
mass.
to the max?
Yes.
But
If
we
the
said
mass
if the
is
mass is
equal, then
equal.
they'll pull at the same time. They'll be like,
Are these pulling differently?
Yeah.
Because of the
No.
Compare F N on C and F C on N.
They're equal.
Yes,
Why?
because
Oh, it's just the mass that is making her accelerate more, right?
yeah.
Because you're pulling it off.
But then why are you moving it all?
Because you have a bigger mass.
Skateboard, no friction.
Now you said there's no, the sum of the forces is 0, right?
Where? What? Where? What?
Is that true?
Sorry, where? What?
In the situation force?
Here?
Yes, the sum of the forces is 0 or no?
On what object?
Oh, yeah.
Okay. On the two together, there are no external forces. So their center of mass doesn't accelerate.
Oh, yes.
But consider him alone. There is a big mass and a little net force, so there is an acceleration. Oh, but anyway, what else is true about things with mass?
That they have a mass.
They take up space.
I guess so, yeah.
There's
Why aren't we allowed to use the word weight in this class?
Because it's only related to Earth. It's only
Okay.
related to Earth.
Oh,
Good.
because weight is relative.
Yeah,
yeah, 'cause if we-
it's not clear.
Alien campus, but-
Okay? If you're tempted to use weight, use instead
Yes.
force of earth on object or mass or force of object on surface. So you should never see a question that every object has weight. But let's see. Every object does have a force of earth on object. Every object with mass has mass. Does an object with mass always exert a force? Well, that's going to take some thinking about. How about motion? Out of everything on your formula sheet, I'm pretty sure there's only one. Well, actually, there's two with mass in it. And here's the second one. Now,
So the sum of all forces is acceleration times the mass.
that's right. You guys, get yourselves on mophysics.com. Listen.
Oh, okay, that's what it is.
Yep.
Mophysics.com.
Listen, some of the students from Block 1 are taking names for a review clinic after school tomorrow. And if you sign up with them, check, I think Jasmine or Charlotte. Yeah. She's taking names. If you put your name down and promise to come, I'll get pizza.
Wait, what? Today?
Tomorrow after school. Get this information and more at mophysics.com this weekend. That'll go here. Okay. Hang on just a second. Signing off. Look for part 3 elsewhere.